Welcome to the Industrial Control System Information Sharing and Analysis Center's monthly public briefing. We'll take another minute or two to give those who are still logging in a chance to complete the process. During this time, I will provide some housekeeping notes. If you're calling in on the telephone, you will find a PIN number on the GoToWebinar application. Please enter this PIN into your phone and press pound. This will allow us to manage background noise. My name is Debbie Wendell, and I will be moderating today's session. I serve as Community Director for the Center and oversee the Center's human-to-human information dissemination mechanisms. In case you are not yet aware of the full range of collaborative products we have to offer, make sure you check out our LinkedIn group, Twitter account, and website blog posts. Plus, we hope that you will take full advantage of these briefings, as well as our Thursday open forum discussion sessions. Our goal is to get our members accurate, timely, and actionable information in a way that best suits their needs. Today's briefing, Mitigating ICS System Vulnerabilities, features Asguard Networks founder David Mattis as this month's subject matter expert and will be hosted by ICS-ISAC Chair Chris Blask. During today's presentation, Chris will take the first few minutes of the call to give a brief center overview and bring you up to speed on the latest developments from the center. Next, David will spend about 35 or 40 minutes for his presentation and demonstration. Finally, there will be a time for questions and answers and open discussion at the end of the presentation. We will be attempting to keep as many of you as possible off of mute so that you can speak your thoughts or raise questions as appropriate. But please mute your headsets or phones if necessary to help reduce unwanted background noise. When speaking, if you would please introduce yourself and indicate your industry affiliation. And additionally, if you would like to ask a question, you may also use the hand raise feature in the GoToWebinar application. After the meeting, a recording of this session will be available on the Center's website. Slides may be available upon request and at the presenter's discretion. Please contact an ICS-ISAC staff member for further information. So now, without any further delay, Chris, over to you for your center update.
Thank you, Debbie, and thanks everybody for coming in or for listening to this. If you're here live or listening to this later, we appreciate your time and attention and all of your efforts to address the issues that we all share together. So as Debbie said, so this is part of our human sharing process. We put together as many opportunities as possible for humans, like all of us, arguably speaking, to share what knowledge we have directly with each other one-on-one. Those include a monthly briefing that we've been doing now since the end of last year, where we bring together subject matter experts for panel discussions and topical conversations and so forth. This is the first or perhaps second in a series of solution briefings. We've talked about this issue quite a lot internally and amongst our membership, and we want this community to have opinions. And those include opinions from those of us who actually do things for a living and have solutions that we think might help the world be a better place to be. So these sessions, once a month, perhaps more for the public and members as well, will focus on solutions being delivered by our membership. So they can be products, they can be services, they can be architectures that can be applied using their preferred approaches. So there will be a specific vendor or provider bias to this. However, we are amongst peers. We're all experts in our own right, and we hope that the listeners will chime in with their own comments and criticisms and questions and hooks and barbs of outrageous fortune to add to the mix. So I'm just going to take a minute or two, as Debbie said, and throw in some updates while we're here. Some of those on the phone I can see are members and folks that we all know. Some are folks who are new to this. So in brief, when we talk about knowledge sharing, we're talking about three things, really. We're talking about identity, inventory, and activity. Do we as a community know who we are and what we're capable of? Do facilities know who they are, what they're capable of? How do they make decision-making processes, that sort of thing. We look at inventory. Do we know what we have? If I'm a facility, do I even know what devices I have in my control system network? Do I know what they're connected to, or do I not? These are very simple questions. And do we know what it's doing? Can we tell what is normal on a facility? Can we tell what's normal in a municipality, in a state, from a national perspective? How do we maintain that? So when we're looking at enabling solutions to create, maintain, and manage and share knowledge, these are the categories that we're thinking about. And as everybody listening to this in real time knows, and everybody listening to this in the near future knows, we're in the midst of a process right now in the United States where the federal administration, the White House, the President has issued an executive order, the Presidential Policy Directive, PPD 21, that amongst other things includes the drive to create a national situational awareness system. And this is not something new. It's been something that's been emerging for a long, long time. It's the reason really this center was created a year ago, was to foster and forward this evolution, this development of shared situational awareness. So right now we're currently creating a reference architecture for situational awareness, which fortunately comes down to a nice little acronym called SARA, and it looks like this. So how do we as a community enable facilities to have the capability to, inside their own operations, be able to build their awareness of who they are, what they have, and what it's doing? How do we work with those facilities, with the solution providers, with vendors, with integrators, with industry organizations, with public organizations, from municipalities to states to federal to international, to allow that knowledge of that information to be shared? And how do we work as a knowledge center ourselves with other knowledge centers to share all that knowledge, that information with others, while still dealing with the privacy issues, legalities, motivations? How do we get all that working? So during this calendar year, we'll be expanding this situational awareness reference architecture. It's a set of documentation, starting with an initial document that defines what we're doing and how this gets done in a portable, open source fashion, with dependencies that solution providers and vendors can expand on their own commercial or however biased solutions that asset owners can choose from. All of this, of course, is to build these knowledge networks, so that as we have facilities capable of being aware of detecting when bad things happen, this can be shared with others externally, perhaps the service providers, the vendors, the integrators, the industry organizations they already have direct relationships with, maybe data and information, actual atomic information about what they have and who they are and so forth. But at the very least, the knowledge of that can be shared with those entities, and at the end of the day with those of us who are a further step away, so that we can know that, for example, half of the water facilities in the southeast states were attacked 5 minutes ago. So for all of this, last note before passing over to David, we need the support of our members. We do not take government money. We're not funded by the U.S. Congress or any place else. We need input of information. Some of our members will not be able to share anything. We're fine with that. We understand. Some of them will. That information can be shared directly, like David's going to do in a minute here, like our panelists do on other discussions. It can be used to derive other information. Perhaps you're a water facility in a small town. You share with us nothing except once when you detect something, and we can notice that this has also been seen by other members, and we can share that with state and federal, national, and protect us from the bad guys. And perhaps we can share information with you, and that can be shared with others. A large, distinct aspect and characteristics of this center has organically emerged as some place for groups to get together. The vendors and integrators have not been integrated very well into the knowledge sharing process to date, and which is why, as it turns out, that a lot of vendors like Asguard and integrators like IBM, SCIC, Prime Controls, and others have gotten involved with us. It's where our ability to share information that we get, to create derived information, share that, and have that shared with larger numbers of organizations, that increases our ability to perform our mission. So with all of that, I want to turn it over to David, let you use the bulk of this for talking about your solution. And I know you've got a demo lined up for us at the end. Following that, we'll have a question and answer. We can talk more about sort of the state of the world we're at right now and how that applies. So Debbie, it's all yours.
All right. Thanks, Chris, for that update. Now for this month's ICS-ISAC featured speaker. David Mattis founded Asguard Networks based on his 13 years of experience in Boeing's research and development organization, where he focused on industrial control system security issues. David was the co-creator of and technical and implementation lead on an architecture that addressed the challenges of segmenting connectivity for ICS devices into private networks while securely connecting them to and through Boeing's enterprise networks. His efforts not only satisfied Boeing's stringent InfoSec governance and security requirements, but also met the needs of diverse end users as well. David's vision for Asguard Networks is to continue to create products that address the challenges of managing connectivity and information security for industrial control system networks. The drive for connectivity from the top floor to the shop floor is a trend with well-documented benefits, yet it can also generate operational risks and vulnerabilities. For those organizations striving to realize the benefits of pervasive connectivity while minimizing information security risks, Asguard Networks provides network security appliances based on the Trusted Computing Group network security standards. This functionality allows companies to leverage their existing core network infrastructure by connecting their industrial assets in a way that is highly secure, cost-effective, easy to use, and ultimately offers immense improvement over traditional VPN solutions. David, the floor is now yours. Please go ahead with your presentation.
Thank you, Debbie, and thank you, Chris. And hello, all of you. Thanks for your time and attention today. That was a great introduction. I think I don't need to give my presentation anymore, but I'll try to add to that. So Asguard Networks was as a company, we're about a little over a year old, and I started this company based on my work at Boeing. I was in the R&D organization there for 13 years, always looking at manufacturing systems and applying the latest in communications and security to those environments. And in 2005, we started working with the 777 airplane manufacturing organization to help them leverage the Boeing Enterprise Network for wireless connectivity as they transitioned from fixed monolithic tooling to mobile tooling for the 777. And it was a fascinating project, and it was one in which one of the goals of the project was to design a solution that could be applied generically to manufacturing systems throughout the enterprise. And furthermore, there was an emphasis on talking about whatever we did in international standards organizations to make sure we weren't just inventing something in a vacuum that we thought was good, but that there was a consensus and agreement. So we worked on this several times over the years, and it became an internal standard at Boeing, and our hard work was recognized throughout the company. And so I left to commercialize this technology, and we are a relatively new company, so I would say this technology, this architecture is fairly mature. It pulled together several components, several research projects already fairly advanced in 2005, and these have all been maturing together as a consistent architecture. So we're all adding more and more connectivity. IP convergence is a trend that has really been unstoppable since the early 90s that saw everything get a network jack. And as Ralph Langner in his great book on industrial control systems says, these networks are very fragile because the networks with automation systems are very fragile because their input range is not adequately constrained. Their network inputs can vary out of design spec, and that makes them very brittle. And so they're also exposed, right? We're seeing many automation systems directly on the internet. We see many VLANs with PLCs on them that have where people have the ability to ping any PLC from the corporate network directly. And many will say these systems are vulnerable by design as well, where the security posture of these automation components has not been the top business priority for the vendors. And then you have authors like Brian Singer saying, you know, the biggest threat to most ICS networks are really vanilla malware because of its aggressiveness at propagating and its heavy use of bandwidth and its ability to find any nook and cranny into an automation environment. And while vanilla malware may not directly infect a PLC or an RTU, its network traffic on a industrial automation network can have a very damaging effect. And also insider, either malicious or accidental impacts. Probably accidental impacts are, I think, ranked quite high in the source of incidents in industrial environments. Misconfiguration, lack of awareness of the security controls that can be turned on, in temporary installation of access mechanisms, temporary changes in security policies. All these things lead to vulnerable automation networks. And it has been my experience that it's difficult to find a solution out there that enables connectivity yet also mitigates the risk of connectivity while remaining flexible, scaling, being cost effective, and really making sure there's a strong working relationship within the organization. Right? We often hear about the cultural divide between operations and IT. That's a very real issue and stems very often from different sets of requirements. We have the whole confidentiality, integrity, and availability battle on IT against availability, integrity, and confidentiality priorities in operations. So as I mentioned, industrial automation vendors have added connectivity very aggressively, and people are using it very aggressively in response to many business drivers. However, the security posture remains, for the most part, back in the 90s. And the connectivity is increasing to the point where today we're seeing a tremendous amount of secure communications needed over intranet, and we are already seeing the need for this secure communications over the internet, as can be evidenced by the by recent studies, say by H.D. Moore and Project Shine, talking about the legions of directly connected automation systems on the internet. So clearly, while the vendors catch up, we need some technologies, some solutions to put in place to mitigate the risk of these automation systems as we add this connectivity. Network segmentation, I think, is a foundational building block of a defense in depth architecture for securing ICS connectivity. The goal of defense in depth is not necessarily to say we're going to block every attack and reduce every risk to zero and remove every threat, but rather we want to slow down the effect of any attack, reduce the number of attacks, raise the bar as high as we can on any attack, reduce the number of attacks, slow down an attack if it occurs so it has the least effect in our environment, and make it faster for us to detect an attack and respond to an attack to increase our resilience. And network segmentation, I think, is one of those basic layers of that defense in depth approach, where we want to limit the connectivity of these automation systems to the absolute minimum and isolate them on the right performance network. And by limiting their connectivity, constraining their connectivity to the absolute minimum, we're going to not only improve their security, we're going to increase the system robustness, because we're going to reduce the number of inputs to which these systems are exposed, because we'll reduce the number of sources and the number of types of inputs. And if we can, furthermore, if we can filter those inputs to make sure they're within specific ranges, then we're doing even better, right? So the challenge, however, of network segmentation is that it really gets down into the network weeds. And we often have these trust boundary crossings that we have to consider, and that becomes very hard. And sharing network infrastructures like wireless, Wi-Fi, cellular, DMZ environments, that becomes very hard. And we need to look at solutions that make this easy and flexible. Traditionally, segmentation has been approached through a number of different ways. Direct connection, right, and do nothing, right, and this is very, very common. And here I think a lot of education is needed in the community, right, so people know that the risks that they are taking when they put a serial port server directly on the internet. A jump PC, a dual-homed PC, a vanilla PC, or a hardened PC that serves as a gateway or jump platform to get into a process environment. The data diodes, I think we're very familiar with these. These are great technology. They're used for a long time in defense and industrial environments to physically limit network connectivity to a single direction. They often require some kind of application proxy to turn inherently bidirectional traffic into unidirectional traffic, and that can make the installation and application of data diodes challenging and expensive. A local security appliance, a VLAN, parallel infrastructure. I'm going to get into some of these in a little more detail. Parallel infrastructure, however, when we see this fairly often, say in electric distribution, where fibers have been laid alongside the electric line, and the distribution companies have now a private parallel infrastructure that they can use for automation. Tends to be a very expensive approach. So yeah, we have the direct connection, and the challenges here, right, are there no protections for the automation systems other than what they can supply on their own. And also, you have the challenges of the protocols that they're using and obtaining wireless connectivity, say, to this shared network environment. And it's staggering how common this still is, to have either systems directly connected to an internal corporate network or directly to the internet. The numbers are for the use are quite staggering. So H.D. Moore's report documented some 13,000 serial port servers that were vulnerable and connected to automation equipment. Project Shine documented some like 7,000 automation, critical infrastructure automation components that are vulnerable. And this is a very high number spread throughout our country. A VLAN is a very common approach. I think we see this very often, to have a process VLAN on top of a corporate network. And the VLAN has to be defined across shared network, terminating at individual network ports on the floor for which the equipment is plugged in. And it becomes a fairly high cost per managed port. And this VLAN is just one user of this shared network environment. And becomes, and what's happening here is that the security configuration is being pushed into the core network, embedded in the core network. And in VLANing, it's a segregation mechanism to isolate traffic. It's often used as a security segmentation mechanism to prevent visibility into these networks, to try and provide some measure of integrity of these process networks. And however, it's very hard to get this configuration just right. And it's also quite easy for the configuration of one VLAN to be affected by changes in configuration of other components in a shared network. There can be many VLANs, and changing any one of them means changing the entire network. And that becomes a very risky and time-consuming proposition that has to be governed very carefully. It's it's governed by federal regulations, even say Sarbanes-Oxley, for regulating changes in the shared network that could have an effect on the business. It's very hard to add mobile devices into a VLAN. It's very hard to extend this VLAN into a different area where there may be wireless. It's and furthermore, this VLAN is often treated as a flat trusted network, or a uniformly trusted network, where every device in this VLAN has equal connectivity access to any other device in this VLAN. And I liken that to having all your eggs in one basket, where if the basket drops, you can ruin a lot of eggs. And so within this environment, we even ought to be considering how can we constrain systems to have far reduced connectivity, or just the minimum connectivity that's required. Having a local security appliance at the automation equipment is another approach, and this could be a firewall, a NAT router, a VPN appliance. There are many industrial and IT products available to do this, which will restrict connectivity to the local automation equipment. And the problem we see with this is it really it comes down to governance and scaling and change management. As these environments grow, making sure that the system configuration is kept up to date is challenging, especially if you want to do things like VPN. What are the credentials, or what are the keys, the secrets that are used for those VPN connections? How can we manage those so that each one is different, so that they can be revoked if a device gets lost or stolen or broken? What if they all have admin passwords? How are those managed? How do we manage change in these environments so that we can allow remote access? And how do we use something like that on a mobile device? Right? So now I get into our SimpleConnect solution for network segmentation. And we think of it as a service, a product that can provide an internal service for segmented secure connectivity within an organization. And so this is before we have our automation systems that we would like to leverage some kind of shared network infrastructure, and we deploy our SimpleConnect industrial security appliances with the automation equipment. You can have a wall of automation equipment, all with a local switch connected to a security appliance. You can have a virtualized security appliance as an app, say on a mobile device. And all the security appliances are all centrally managed with our SimpleConnect management platform. And each security appliance has a unique cryptographic identity, and these identities are grouped together into a collection, a whitelist, that determines which security appliances can communicate with one another. So we create this private network environment based on a cryptographic whitelist, and the security appliances establish point-to-point VPN tunnels with each other to allow the automation equipment to communicate with each other. And the security appliances create this security boundary across which there is no visibility in either direction. So there's no network visibility or routing across this security boundary. So the shared network sees only encrypted data moving between security appliances, and the automation equipment has the perception of being directly connected to each other on a local switch. And this is a transparent drop-in solution for securing the connectivity of these automation components over a shared network environment, where it's transparent to the automation equipment because they have no perception of this shared network other than its inherent network qualities, its inherent latency and availability issues that may be present on that shared network. But broadcast and multicast protocols, they just, to the automation equipment, it looks like they're all directly connected to one another. It's a single broadcast domain. The security appliance provides that authentication, confidentiality, integrity, and policy enforcement on behalf of the automation equipment and connects to the shared network using any kind of link type. So it could be Ethernet, cellular, Wi-Fi, and performs that network authentication to the shared network. This depicts some of the communications flows that are happening. So we have our management platform, which presents a web-based user interface to a user or administrator. The security appliances communicate with the management platform using an HTTPS web services protocol based on Trusted Computing Group standards to obtain their private network memberships, so this is that cryptographic whitelist, and their security policy configurations, and their network rendezvous information. So how are the security appliances going to communicate or reach one another when they need to establish these tunnels? And then the security appliances, in response to communications, will establish VPN tunnels between one another and enforce policy that can constrain the automation equipment's ability to communicate through this private network environment. So we can add policies that say limit this server to communicating with this PLC using, say, Modbus TCP, and communicating with this water flow meter using, say, OPC, and communicating with this tablet, say, using HTTP, right? And so we can prevent this flow meter from communicating with this PLC or from this server from communicating with this other PLC, right? We're not going to be doing anything about the communications within this automation cell. This typically will be a very high-speed, real-time control network. But for the purposes of doing SCADA, we want to be able to extract data out of there. We want to occasionally allow remote access into this environment to view or maintain the systems within it. And we want to make all these private networks very easy to manage. This is where the management platform really comes in, is it treats each of these private networks as an individual entity. So a user group needs a private network sandbox. You simply give that private network a unique name and add the identities of the security appliances to that private network and delegate the management of that private network to the people that are responsible for it, so that those users can define the devices that are associated with each security appliance and define the security policies that constrain the connectivity to the absolute minimum. And if we make this very easy to do, then I think that people will do a good job of that. They will minimize the connectivity. They will enable policies that make the system work the way it should. It will disable policies that are not needed. They will allow remote access on an as-needed basis. And yet the entire configuration of all the private networks is centrally governed and monitored, right? So there's an audit log of who did what when to change the configuration of these environments. And the goals of SimpleConnect really are to leverage that shared network infrastructure to minimize cost. And it's not always going to make sense to have a shared network, to leverage a shared network, but in many cases it will. And even if you have an isolated parallel infrastructure, it can still make a lot of sense to segment that private infrastructure, that parallel infrastructure, as an added security layer. We want to isolate these industrial systems from that shared network and use a security model that's been designed from the ground up to support the authentication and identity management of these on behalf of these automation systems. We want to be able to apply network segmentation in a dynamic and flexible way that we can make sure the connectivity is at an absolute minimum continuously. You can minimize the attack surface. We want to, this notion of delegation is really, I think, extremely powerful here. We want to allow automation engineers to manage their own devices and create the clear line of responsibility between people who operate these environments and people who support and maintain that shared network infrastructure. Let's bridge that cultural divide and let them meet in the middle and each have their piece of this. And this should all be defined in international standards, and it should not be very expensive to install and operate this kind of environment, and it should be an enabler of additional defensive measures, for example, using data diodes in an environment. We should make it easier and less expensive to use data diodes. The standards upon which SimpleConnect is based are being published by ISA in this technical report 100.15.01, which talks about secure connectivity over untrusted or trusted networks, and aligns very well with the ISA 99 zones and conduits model. The Trusted Computing Group is publishing standards to support network security automation. They have this interface for metadata access point standard, which is kind of like social networking for automation, social networking for network security, and specifically a metadata for ICS security specification, which is, like the social networking for automation concept. So it's a publish subscribe semantic. It's a web service that was designed to scale to very large numbers of clients by using this publish subscribe model. And the industrial security appliances and the management platform use the IF-map as the coordination mechanism. They also, the appliances also cache their policy configuration in case this IF-map service would ever become unavailable. IETF have standards for public key infrastructure, of course, and these identity-based VPN tunnels. And these standards are vital for both the vendors and the end users, right? So that there's community feedback, peer review, consensus agreement for the vendors, and that the end users have some hope for interoperable products from different vendors, competition, and innovation, and a lower total cost of ownership by seeing multiple vendors by product. So our SimpleConnect product line is comprised of two components: this management platform, which is required to deploy and manage the security appliances and to change their configuration, to monitor them. But the security appliances will always continue to run with their with their known configuration, with their cached configuration, if the management platform is ever to go offline. Zero is our goal for training and touch labor cost of this solution. We have a very intuitive web-based user interface, which I'll demonstrate. And our industrial security appliances, these are designed to match the fit, form, and function of the environments in which they're installed. And so we have several different models of these, different form factors with different environmental ratings, including high throughput, data center grade type concentrators, virtualized ISAs, application-based ISAs. And these are connecting to the shared network resource with a variety of media. These are some screenshots of our network provisioning. It's as simple as creating a private network and giving a unique name, adding security appliances to that network, and defining the devices behind each security appliance. It's very simple to use and create a private network. And then there's a policy configuration step, whereby we're setting host-level policies for the devices behind a given security appliance and defining the peer-to-peer level policies for the appliances within a private network. And let's see this more in the demo. Here's a basic example diagram in which a DMZ has several services that are being accessed by several substations. And there's a security appliance deployed at each substation that's attached to the shared network infrastructure. There's a security appliance in the DMZ environment that's attached to the shared network infrastructure. And rather than use a VLAN or pull parallel infrastructure to each of these substations, we are creating a private network overlaid on top of that shared network infrastructure. So this is that security boundary. And policies and each of these security appliances are added into this private network. We'll call this Secure Private Ops Network. Automation devices are defined behind each of those security appliances, and policies are defined that allow certain components within each of these substations to communicate with certain components within the DMZ. And remote access can be turned on and off as needed for remote engineers to have specific constrained access to only certain components on an as-needed basis to ensure that, and the policies can be used to ensure that the remote engineer is indeed only operating on the equipment that needs to be maintained. And we can have another private network environment shown up here on the top that's, say, used for test and development. And this is a totally independent private network, independent from this one lower down. Yet, just by changing the memberships of these private networks, a security appliance can be moved from the test dev network to the production network and back and forth very easily, say, to test some new code or replace a device. And all of these environments are managed by the management platform. Here's an example of leveraging the internet for data monitoring of some water stations. So in this example, a cellular-enabled security appliance is installed at each station, and a private network is created that allows components in this station to communicate with components in an operations center. And these communications are now going over the cellular network, but are completely isolated from it. And the network addressing of these components is completely independent of any addressing that the cellular provider hands out to the security appliances. So we can now avoid using a custom cellular network or APN, and instead just rely on the vanilla cellular network. That we are carrier provider independent. We could switch providers, switch carriers, and on top of those on top of that cellular network, we are overlaying an independent, isolated, policy-constrained network environment. And similarly, if a remote engineer has a cellular security appliance, they can use it to connect anywhere. They can get cellular connectivity to connect into these into specific environments on an as-needed basis. So the service model is that our customers purchase our equipment, install the management platform on the shared network, and there's the concept of an administrator, which will create the private networks in response to a request from their internal customers, and delegate the management of that private network to internal users. And those users now have configuration control of the private networks they're delegated to manage. And they can deploy and configure the security appliances for their connectivity needs. And the security appliances are deployed with the automation equipment, and there's no configuration change required to your automation component. It's a transparent drop-in solution. And security appliances can be assigned to remote access for remote access. And where I think SimpleConnect really adds value is that it lets IT provide this service, right? Secure private networking as a service. And yet IT can do this with very low touch labor because they're delegating the control of these private networks to their users. And it's these users that can have this now network configuration control over their environment. The users who understand their environment, they can now modify the configuration on their terms, yet the governance and oversight is centrally administered, and there's a clear audit log of who did what when. And these smaller segmented networks, I think, are going to be easier to maintain, fix, operate, troubleshoot, because there's a much smaller volume of connectivity, much smaller surface of connectivity. And for the organization, there's now a clear, bright line of responsibility over, between IT can maintain these shared network environments, the shared network, and the operations can maintain their private network environment. There's a reduced attack surface because connectivity is now being constrained to the absolute minimum. Connectivity is being completely isolated off of the shared network. The data of the control data, the monitoring data is integrity protected. So we'll have more robust control system environment. Okay, let me switch into the demo. And we're going to look at this network diagram for a utility in Alaska that we've been working with. And they have several sites. I'm just going to show 3 here. And they have a corporate site where the SCADA supervisors work. They also have some viz boards they want to have running. They have an Ops West and an Ops East, and they're doing electric generation. They're doing water treatment and fresh water, and at some different sites that are separated by significant physical distances. And they have this blue network is a shared network WAN. And on top of this environment, they would like to have several different private network environments. And so this is how it was implemented or designed, is to have a security appliance for the viz boards. And these squiggly lines represent private network connectivity. So the viz boards would like to have connectivity with a historian at the east site and a historian at the west site. Furthermore, the SCADA supervisors would like to get to other services within both sites. And when a contractor comes on site, they'd like to give the contractor a wireless ISA and allow the contractor just specific access to certain components within this environment. and they have a contractor at another site. They have SCADA technicians at each site, and they would like to give them connectivity from their desks into the SCADA environment. And so if we look at the management platform, I have in here, this is our dashboard, and I'm going to create a private network, and we're going to call this the VisBoard network first. We'll do this one. Connect VisBoards to multiple sites. So there's a nice element of documentation in the management platform, and then we add security appliances, and I'm going to add the VisBoards ISA and the Operations East Historian and Operations West Historian. Okay, so I have, go back to the Visio. I've created a private network for VisBoards, and I added this security appliance, this one, and this one by these. And now I'm going to define the devices behind each security appliance. I have a VisBoard, and I'm going to add an automation device, and we'll call this VisBoard 1. And now, as the automation user, I'm in control of what this IP addressing is for this environment. It's independent from the shared network that I'm leveraging. So we'll just call VisBoard 1 as 0.10. I'll add VisBoard 2. And I'm going to allow both of these to communicate through this security appliance. And I also have to define how the security appliances can connect to one another. And so I'll enable the VisBoard security appliance to communicate with both the operations ISAs. And then if we look at the Operations West ISA, right, it has corresponding peer policy with the VisBoard ISA, but not with the Historian East. I'm going to add the device here. This will be our East Historian. And we're going to allow it to communicate through. And type that, our West Historian. And we're going to add our East Historian. And allow it to communicate. And so now I have just, in this short amount of time, defined a private network that allows these VisBoards to communicate with these historians in an isolated, policy-constrained way. And so we'll notice, too, that this historian at West does not have a policy that allows it to connect with Historian East. We're constraining that connectivity to the absolute minimum. Now, if we want to allow the SCADA supervisor at the operations center to communicate with some equipment, we can do that as well. So networks, we're going to add a private network. We'll call this the data management network. And here I just want to show you this notion of delegation, which I didn't show you yet. But we can define roles for our users. So we want our the SCADA manager to manage this network environment, to be able to control, to define the configuration, and you know we want, but we want the Ops West manager to have just a read-only visibility of this configuration. So we'll make them a member. So now these users can log into the management platform, and the SCADA manager will be able to manage this network environment, but the Ops West manager will only be able to view the configuration of this environment. And so we'll add the security appliance. So I would notice that when the security appliances initially register with the management platform, they show up using their unique ID that's part of their cryptographic material. And this is all defined as part of the standard. Then we want to make it easy to give these security appliances human-friendly names, right? So, so that we can actually define them, recognize them easily within the system. And then we'll go back to our network. So it's our SCADA Ops ISA, and we're going to add the Ops West ISA. And so now these policies are different. This is a different network. So we have the SCADA Manager PC. And we're going to allow it to have connectivity to this historian. And if we want to have also a network for remote access, we can define that and add security appliances to it. Say we're going to do some work on the viz boards today, right? So we can now allow that connectivity. We'll call this the Bastion host. And we're going to allow it, today that they only need to do work on the VizBoard 1 PC server. So we are adding these layers of connectivity policy control on top of this shared network in a way that can be independently managed from the configuration of that shared network. When you take the security appliances out of the box, you can use a variety of mechanisms to register them with the management platform. You can either use DNS, which makes it very, very easy to do. DNS can provide a resource record for the management platform. And the ISAs, when they connect to the shared network, can ask DNS to point them to that resource. And the ISAs, when they are out of the box and in factory reset condition, they will connect to the management platform and register themselves, and they will show up in the management platform as an unassigned security appliance, one that's available. And then once it's joined to a private network, it's in a different state where it has additional privileges to connect to other security appliances within that private network. If you would like to set a wireless network for, say, Wi-Fi connectivity, you can define that connection within the management platform, and that connection information will be sent to the security appliances. Obviously, they need to connect with a wired connection first in order to retrieve that wireless configuration. I think that wraps up the demo. I would like to leave plenty of time for questions and turn it back over to you, Debbie and Chris.
All right, thank you. Thank you, David. I think, Debbie, you've got a transition piece to say here, but while I have the floor, there was one question that got sent to me directly. Deb, feel free to jump in if you're out there. Otherwise, I will.
All right. I was talking to my mute button. I'm very sorry.
Isn't that great? We all do that.
It's fun. Yes, we all do that from time to time. All right. Thanks, David, for that briefing. Some really exciting things there. Some great points to feed the discussion. We've got a couple questions already, so we're going to go ahead, like Chris said, and open it up. And again, folks on the call, please, as we identify you, introduce yourself, indicate your industry affiliation. A couple people have already entered some questions there in the GoToWebinar application. You can go ahead and do that also as an option, or use your hand raise feature, and we'll unmute you so you can ask your question. All right, guys, go ahead.
So the one I had early was, and I think it was mistaken. So I'll try to interpret it a little bit, but it was, what pushback did you get from Boeing for a bump on the wire solution? So it's not, but this is not a device that goes between every PLC and the outside world, right? So it's not going to be that type of thing. It's segmenting out other issues. But I think to expand that a little bit, since you developed this inside Boeing, the why not question comes up. So if you could, what issues did you struggle with? What resistance was there? Do you have comments along those lines?
Sure. Well, there's always a struggle to introduce something new, but it really came down to there was really an environment of mutual distrust within Boeing. I think this is pretty common, where the operations people, the manufacturing people, don't trust the Boeing network. Don't trust the Boeing. Don't want to put their tools directly on the Boeing network because they don't trust the Boeing network, and the IT folks, they don't trust the tools to go on their Boeing network, right? So mutual distrust, and providing a capability that satisfied them both in a way that they could both understand and say, yeah, okay, we agree. That was very hard. But ultimately, IT wins that fight, because they can turn off the connectivity, right? They control the shared network. So there's a big challenge in just embracing something new, packaging it correctly so that both sides really recognize the benefit that it would provide them. Over time, early on, we had significant challenge with scaling this capability, right? And so, that was when we first got going. This was prior to knowing about the TCG standards for network security coordination, and everything was done using, all the security policies were coordinated using LDAP or database, or even local configuration files on the security appliances. And over time, we really found a way to address that using TCG standards. So there have been both technical and policy hurdles along the way that we had to address.
Thanks. So you said that so the company's a year old. Are you shipping product now, installing it out in the world, getting sector to sector? Is it, if so, is it, or in your conversations, is there a sector-specific pickup or resistance that you're seeing out there?
I think so. We are shipping product. We've had our product for sale now since the end of last year, and we are getting traction in water and gas distribution, water, wastewater, gas distribution, manufacturing, and interest also in the utility, electric utility space. So those are the sectors where we're focusing and talking to a number of people.
Yeah, because just in the usual cross-sector view of things, again, we talk so much about the electric grid, and we have so much focus on that, and it is the one area that actually has some compliance issues. It's personally, I'm interested in that pickup and that adoption. So you're coming from manufacturing this time in Boeing, and that sector list you just ran through, you come to electric last, which is sort of interesting. I don't know if there's a sort of industry lesson from that. I kind of read what I might have expected, coming into this, that electric is a little more problematic. Is that the case, or am I just projecting?
Well, yeah, I do think it's electric is hard because right, there's the regulatory environment, and it is so they seem so constrained by the regulations that, and then trying to figure out, well, exactly what is SimpleConnect going to do for me in this regulatory environment, and and that test of will it pass an audit, right? And so that does make it harder to get into that environment. I think exactly where it sits with respect to the regulations is and the regulations are changing, so it's still a little unclear. I think we're moving a little more slowly, I think, in the NERC-CIP regulated environment because of that.
Yeah, and perhaps that's another question about, this really not on topic we were talking about too much, about the Amber Alert from a few weeks ago and the executive order and so forth, and how that all fits into things. But it's this topic resonates of that. Since we have regulations and mandates and so forth are discussed an awful lot. Where we go with all of this, whether you're talking from the executive order level down and whatnot, or sector to sector. But in the one sector we have regulations, as the experience of a one solution provider out there that's come up with something that can be used. Your experience and ability to have success and work on systems per sector, and that comment you just made about regulation. I don't know. It plays into that. I'm on record as saying that I think we're kind of stuck with regulation. I think that we have to get to the point. I mean, ideally, I'm as libertarian as the next guy. I'd love to see us all in the private sector do this all independently on our own. But in as much as you're connecting your critical infrastructure that people are relying on to the outside world, do we have to get to a state where Big Brother, or at least Big Daddy, in the government has to come along and force us to do things a certain way? And if so, what are the downsides of that? I think we all know that's NERC-CIP is the folks at NERC are doing a good job. They're trying to do everything they can, but we come back to these artifacts again and again, where it's harder to get things done because they're getting more locked down. I don't know if I'm leading to a question there, but it's
well, and that's just it. And I think we need to look beyond compliance, right, and continuously be adopting, or advancing our defenses, right, and implementing controls that make sense, not just because we're checking the box, but because they enable us to run the business. They enable enterprises to run the business the way they need to change the way they run the business when they need to, and to do it in a way that's that's really advancing the network security state.
Yeah. And Debbie, I don't know if there's any other questions out there. The one thought of just before this, I was talking to one of our members that's a municipality, and this is I'm always coming back to this, and if I understand things correctly, the stuff you guys are doing and this kind of approach has some plays in that sort of space where it's where we are going to interconnect things. A municipality is a perfect example. We've got power and water and building management, traffic management, who knows what else under your belt, and you've got some perhaps shared municipal communications infrastructure. The kind of things that you guys are doing, you can then leverage that instead of building more. So you save money, which is always important to everybody, but cities never have any cash. So it makes it easier and cheaper to be more secure and have a more consolidated infrastructure. That's right. Safe to say, or am I?
Yeah, no, we see many counties have a shared network environment, and very like based on a microwave ring and MPLS, right? But there are many users of that network, and And they would like to see a layer of isolation between them and the other users that's independent of that network itself, right? And to also then, so now you're talking about an existing private network infrastructure, right? And this would be, a corporation, a manufacturing environment like Boeing, they also build up their own private network infrastructure, and it happens to be linked over WAN links using ISPs, right? And a lot of municipalities just build up that shared network infrastructure using, say, microwave towers. But the same notion where there's a network infrastructure, many users looking for a layer of isolation from that network that provides additional security, control, and segmentation. Additionally, if you want to leverage a cellular network, who's going to, the cost to, implement a network infrastructure, radio infrastructure to reach far outside where there's cellular service available, and the cellular service may be adequate for, from a reliability perspective for maintaining that view, that control view. Well, why not take advantage of it, right? In many cases, it won't make sense, certainly.
Yeah, well, it's the of course the air gap is always the elephant in the room conversation. I'm going to build this system. I'm not going to connect it to anything. Therefore, I have no problems. And that's always so often not the case, and in reality, almost never the case. And then if you need to interconnect, then your costs get sort of out of control. So finding ways.
And even within the air gap network, if something does get in, you want to really delay the propagation of whatever got in, right? So that it can be confined and dealt with, right? So can we reduce the degree to which things are connected even within an air-gapped environment? Yeah, we can do a lot to do that.
Yeah. Neat stuff. So, Debbie, are there any other questions we left unasked, or should we?
I have one. I have one myself.
Okay.
David, you talked about during your PowerPoint part of this about delegating control of the private network out to the user. So the actual owner of the appliance gets to define their own credentials, I guess is how I'm reading that. Then if that's the case, if I'm an owner of that appliance in my department, in my area, and it's my thing, how is it defined that I can allow or disallow others in the enterprise to be able to access it or view it or not? Is that overall defined at the enterprise level that says if you have this kind of system and it's being used, or this kind of appliance and it's being used in this way, you have to allow this sort of access to it?
Yeah, so that takes us into the different roles that we provide, the role-based authorization we provide in our management platform. And once an appliance is placed into, assigned to a user group, delegated, and placed into a network, only other managers only managers of networks in which that appliance is assigned can make security policy changes for that appliance. So there really is kind of this sense of ownership, because you don't want people making security policy changes on your appliance, when they're not authorized to do so.
Right. Okay.
Does that make sense?
Absolutely. Thank you.
So, and then, yeah.
So we had just looking, I see there's one question out there on the electric, and can you comment on installing a regulated environment? I think we talked about that with inside NERC. So just any other thoughts? So inside NERC, have you positioned specifically in that?
Yeah, so definitely, and I think within NERC we we sit on that, electronic security perimeter as an access point into control system components, and as such, we have to be a managed device within NERC SIP. There has to be all the documentation, the user management, et cetera. And so the management platform itself can help reduce the administrative burden of complying with those regulations, while enabling this kind of secure connectivity that's needed to stitch these different critical assets together. So the regulations are what they are. We're not going to make them go away, but we're going to, by applying SimpleConnect, the burden of meeting those regulatory requirements can be reduced. So you also get the kind of the change management aspect. We can make patch management. We can easier for your control system environments by moving them in and out of different electronic security perimeters for dev and test of those systems. We can make it easier to meet requirements, that the SIP requirements on the critical cyber assets, by giving you a tool for flexible connectivity, right? And so it is a bit longer discussion to have. So that's a quick summary of it.
Yeah, so NERC is always a longer discussion.
Yeah.
So I think that covers it for the Q&A section. We're 10 minutes before our maximum time, and we'd like to get these wrapped up in a time that people can actually consume them. So just to Debbie will have a wrap at the end of this. Last comments for me. General comment that we continue to be ever more interconnected. I know David, with his comments and views and perspective inside Boeing and now outside in the vendor space, and the solutions they're providing, has me thinking more and more about this. Again, not that all the time, but we're all connected to everything else. It's a twisted future, to put it in at least that context. And we see this all the time. So one question earlier on about the Amber Alert. For anybody who doesn't know this, there was an Amber Alert from ICS-ISAC a couple of weeks ago on active attacks to power and perhaps water systems. It wasn't shared, frankly, really well. Even inside the federal government, it wasn't shared very well. It was shared with asset owners, but it wasn't shared with vendors and with integrators and others. And that by itself has been the cause of a lot of interesting conversation and introspection, because at the end of the day, we are all connected to each other, both technically as well as operationally and organizationally. Each of you who are here today, and each of you listening to this in the future, by nature of the fact that you're interested in these sort of things, you're probably in contact with a lot of other people who are as well. So how we manage that interconnected nature of our industry and of our infrastructures is, I think, the critical point. We're past the stage where we can isolate ourselves. We'll either stand together or we'll fall alone. So the next briefing we have is June 19th on data diodes. I know Debbie has some information for you all on that, so I will pass the baton to her. Thank you all, and let Debbie dance us out.
On behalf of all of us at the ICS-ISAC, we appreciate your joining us today. We hope that you found the information of value and something that you can take and implement to further secure your industrial control systems. Our next member briefing will be held Wednesday, June 19th at 1 p.m. Eastern, and features Andrew Ginter, Director of Industrial Security at Waterfall Security Solutions, presenting Stronger Than Firewalls, Unidirectional Gateways in Defense In-Depth Architectures. That will be followed on July 17th when Gary Sturdivant will be providing insight into cybersecurity for water and wastewater. Other sessions will be announced in our monthly updates, on the Center's website, and in our other communication vehicles. And again, we want to thank you for your participation on today's call.